everyone. Welcome to another episode of AI That Works. We are back. And I think today, one of the key things that I'm really excited to talk about is a concept that has come up a few times in our past streams, but it's really about how to build working AI pipelines. So for everyone that hasn't attended before, this is a show called AI That Works. Every week, we run a live conversation where our goal is to talk about how to build a pipeline that actually can make real productive examples. If you find this sort of stuff interesting, check out our link, and we'll usually post new events there. And we run this every single Tuesday at 10 a.m. For about an hour, and the goal is to get to coding as soon as possible. My name is Vaibhav. On the side, I work on BAML. And today I have with me a special guest. Dexter sadly can't make it today, so for all of you that are hoping to see him, I'm really sorry. You're stuck with just myself. But luckily, we have Anders on to make it a lot more interesting and fun.
Yeah.
Anders,
Hello.
do you want to give a quick intro about yourself? I know you're a YC founder. I have gotten to know you for quite some time now.
Yeah.
And I think
First of all, is my mic working
yes,
properly?
we can
I'm
hear
not.
you.
Okay. All right. Uh, yeah. So yeah, it's been a while since we know each other now. But yeah, so we did the YCS 25 batch, but basically we're building SageKit, which is like a workflow automation platform. It's kind of like ChatGPT meets Zapier. Like you just sort of chat and it builds you like workflow automations. So yeah, very key thing to our product experience is just having like a super good like chat experience, right? So there's a lot of things involved in sort of making that kind of experience good, right? And like making sure that yeah, users always have sort of the right thing happen at the right time when they're on our platform. So
Yeah, and I think the first time we met is actually when you were working on a thing called Magnitude back at that time.
yeah,
And for everyone else that we're going to talk about today is we're going to talk about event-driven actions. And why are we going to talk about event-driven actions? Well, because I think it's one of the most interesting ways to go model how to go build agents behind the scene. And we'll get to the whiteboards really fast before we get to coding in a second. But the reason that we brought Anders on today is because I think Anders built their first thing called Magnitude, as I mentioned before, which was an open source system. And I think you guys did pretty well on Hacker News. They got a bunch of GitHub stars around it. And I think the way I described it was kind of like browser based, but worked. But
yeah,
worked.
yeah. That's a good way
Um,
to describe it, basically. Yeah,
it's just like I think you hit number one on all the benchmarks for a while,
yeah.
and then
Still,
eventually
still, still,
start
they are.
still are number one on the benchmarks. I know a bunch of the YC companies that are in that space all use you guys. I know a lot of startups on there use you guys.
Yep.
And I happened to meet you because I guess you were using BAML at the time to go build it.
Yeah.
But through that interaction, I think eventually you settled on this really interesting product idea, which was along the lines of I think we had a whiteboard conversation once about it while we were hanging out about how to build event-driven actions. And I remember we were just like vibing and conversing about it, but it sounds like you guys did it to like the nth degree.
Yeah.
So before we get really into it, how about we just show people what it feels like, and then we can talk about technical architecture and everything else once people get a sense of what does it mean to have an event-driven action? Because I think it can feel so ambiguous along the way.
Right. Yeah. Should I go and share here?
Yeah, go for it. Screen share.
Shoot. Oh, sure. I gotta rejoin real quick.
Cool.
Um,
While everyone else is on here, for everyone else that's joining, how many of you have actually built event-driven actions by chance? Has anyone built a kind of system that can be really almost feel natural? I think the closest that I have seen is probably Claude Code, to where you can interact with it as it's going. And that was one of the first innovations that they had. And I think that's what made Claude Code personally so good. And then obviously Cursor copied it, everyone else copied it. And everyone had the very simple thing that you could do, which is as you typed code, you actually could cancel the previous message and make it go work. But Claude did something very interesting on launch, which was a queue to message. And that behavior pattern I thought of queuing messages was foundationally different than everything else in a very subtle but massive way. I think very similar to a lot of the great UI innovations like Amazon's one-click buy so subtle. The fact that you can just one click check out without having to do anything else, but it makes a huge difference. And I think in AI stuff, event driven and like interruptions and queuing, all these other behaviors are really the difference between like an okay app versus an amazing app. We've got someone working on it right now. That's great. So Anders, let's show the demo and show how it works and how it feels.
Yeah. So first of all, just generally speaking, right? So this is like our sort of chat experience, right? And
So
it's
let's
like,
say what I want to do is I want to go scrape Reddit, subreddit or r/langchain for everyone complaining about structured outputs or complaining about langchain. Let's do that. And the category and categorize the types of complaints.
Okay. We'll ask it a question after. So, okay, let's make a modification.
So it's interesting. What you do is you actually ban the inputs during certain time periods when you don't allow interruptions.
Yeah. Okay, so let me extend the plan there. So, okay, so just to be clear, yeah, we don't, basically over the past couple of days, I was rethinking how sort of the events should work in the chat and like how we should best enable like stopping and interruption and queuing messages and stuff like that. So this is not actually in our production chat app yet, but I have like another demo that's just like I basically used when I was prototyping the new sort of architecture. But this is just sort of a general idea of like types of flows that you have in sort of a very interactive chat app. So it's like you have, back and forth messages, you have, plan approvals, stuff like that. A lot of the same stuff that you have in like interfaces like Cloud Code and that kind of thing. And so if you weren't logged into like some of these apps, sometimes you would get like OAuth flows happening in the middle here. So there's a lot of like complex states that kind of come up that all just sort of like happen in the chat. So it gets sort of like interesting to basically manage all that state and like figure out what should be happening at a given time. Like at a certain time, like should the user be able to send a message? Should they be able to interrupt it? Should they be able to authorize with a certain like OAuth connection? And yeah, so there we go. So it's basically just built a workflow for us. And this is sort of like a summary of what it's going to do. So it'll like use Reddit, review them for complaints, and it'll use like Gemini to analyze them, and then it will format that. So yeah, we can just run that basically. So it just builds it all completely on its own. And then we run it, and it's basically like using the Reddit connector to list the posts, and then it's making a bunch of AI calls to analyze them for complaints.
Makes sense.
Yeah.
So how do we so talk to me about where would you add interruptions? Because we've talked about this a bit, and I think you have like interruptions and queuing. So it sounds like I can definitely send a bunch of messages, but this looks very linear.
Right. Yeah. So what you really want to be able to do, right, and which we're adding like tomorrow or something, is you want to be able to just queue up messages however much you want. Like right now, if I like type another message,
it should just do stuff.
It should just do stuff, right?
Yeah.
And it's like I can send another message, but I can't send another message here. Right now, it's just an invalid state.
Yeah.
But ideally, like, yeah, people want to be able to like send more messages. Like maybe they have a thought while it's building, so they want to keep being able to like send things. So here's like, right, just a demo of sort of what the new architecture vaguely looks like. That's sort of like very just event driven to the max. Yeah, let me zoom in. This is
and then we'll take a look at the code pretty soon too. But I think I think it's one thing I find really fascinating is always when we're able to go look into this in a deep way and just go check this out.
Yeah, so if I can just say hi, and there's not auto scrolling here, but you can see it stream back a response, and these are all just sort of like events like coming from the LLM that are eventually streaming into the chat. But right, we might have other types of events. So it's like tell me a long story. It's like another type of event is like interruption, right? So if we interrupt, that happens sort of concurrently during this process of streaming. And then the question is like, okay, how do you deal with that event in the context of like, okay, we're also streaming from the LLM. So like what's happening now based on those events that occurred, right? Those like the sort of source of truth in terms of like, we started the LLM response, it gave these chunks at this point in time, the user pressed the stop button, what should happen now, right? So it's like, basically reacts to that. It's like, okay, I need to stop, listening to the LLM. I need to, present some sort of message that sort of reflects what the user did. And then, put the user back in a valid state where they can send more messages. So yeah, the user can also just, queue up messages as well, right? And you sort of have to think about like what you want the behavior for queuing to be like. We've sort of followed like the Claude Code model here, where it's like if you send a message, it will start like responding to it, and then if you like queue up more messages, it's like tell me a long story. If you like send a bunch of messages during this point, it'll just sort of like accumulate those, and then once the LM is done with its story, these will basically all like resolve into the context window. So it will like see all of these at once and then respond again.
So I guess what I would say is like, let's talk about this a little bit more. So what I'm going to do is maybe we should jump to whiteboards. Because I think that often it might be an easier way to go describe this kind of state, because as we go see this, there's a lot of complicated things that are happening. One is I have this chat thread that's running all the time. I'm guessing in some backend API call, because it can't run directly from the front end.
Yep.
And then it sounds like the most complicated thing here is what I'm really doing is I'm sending a bunch of commands from the front end, and then I have to update the world view and somehow send a view of the world view back to the front end. The analogy that I've always personally found here is actually video games. If you ever play like a multiplayer video game of any kind, that is, I think, the closest analogy to building these kinds of agentic systems. Because, like, for example, we might have totally different lags in the world. And what if I'm running and you like shoot me? In your scope, it might actually look like you actually landed the shot and you killed me. But from my perspective, I'm lagging, and the worldview, it didn't actually hit me. So, what video games actually do is they actually say we favor the person that is like killing the person, because if it looks like they killed you, it should actually kill you even if you can't tell. And they actually snap correct in that way, because it feels really bad to feel like you did the right thing and then someone else, because of their internet lag, didn't, and world state kind of lied based on what you thought. So,
it's basically like, you have all these events happening, right? And it's like, what you show to the user is always some variation of a lie, right? It's like, it's not the exact, you're not showing them literally every single thing that happened, right? It's like, if you showed them like the exact like function calling format that the LLM used and the exact tool results that the LLM got back and all this kind of stuff, like basically what you want the user to perceive is like different from the truth, and it's different from what you want the LLM to see also. So it's like everyone needs a different version of the truth. And so it's like, how do you manage that? And then how do you manage like the concurrency and stuff?
Yeah. So what we should do is we should actually go ahead and talk through what's it called. Let me open the whiteboard really fast so we can actually draw this out, because I think it's going to be a lot better. And I'll send you the link as well. Give me 1 second. Share screen. Scala draw. Take over Scala draw. Invite. Sorry, I should just invite you. Sorry about this. Dexter usually does this stuff. Live collaboration. Sorry. And then I'll send this to you only. So while we're actually going to talk about this, what we really want to do is we want to figure out a way to go draw this out from a system architecture. So what we have is we have a front end. And in our front end, what we're going to want to do is we're going to want to send a regular system of events to our backend. And once we send system of data to our backend, what we want to make sure is whatever this is triggering should not directly trigger the actual it should not trigger the direct, the direct agent loop. Because if it triggers the direct agent loop and it responds directly to the user in a very linear way, we can no longer interrupt the system. So what we need to make sure that we do is we need to go ahead and somehow send data from the front end to the back end. And once the backend is gone, this needs to kick off some task in some form factor, where this will go write information to some central database. Task. And then somehow this database is, or database-like thing, and somehow this front end will listen to state actions coming from the database. And now what you can do, at least, and correct me if I'm wrong on this, Anders, and you guys do something different, because I think it'd be a very interesting conversation to have, is as events come in, as new events come in, you can basically have your agent tasks somehow be loading these events from new events can also be written to the database, and then your agent task can also have a read-write system from here somehow.
Great. Yeah.
Good.
Yeah. So, yeah, the way I think about this, right, is that right, the event stream and the events produced, they're coming from a lot of different places actually, right? And it's like,
okay.
So it's like you have different sort of types of events that I think about, right? So this is like, right, so this is what, like the user over here. This is right. So, I mean, obviously we have, an LLM in here. Well, this is a very different style. It's going to be an interesting graph.
I can fix that. You can just keep drawing. I'll fix it.
Right, but we have a lot of different things like contributing to the event stream, right? So it's like we obviously have an LLM in here. We have, we have some kind of strategy for, especially with streaming, like we usually have some sort of way of like interpreting or like parsing what the LLM is doing. So usually it's actually like this. It's like we're doing that, and then that's going into the event stream. And then we sometimes have, like handling for like doing different like tool calls or other things. So it's like we have some like tool calls, and maybe sometimes the parser goes and does a tool call first, and then that becomes sort of like an event, right? So it's like there's a lot of different things that can sort of contribute to that, right? And sort of think what the confusing part becomes is like, okay, how do you, who's sort of in control? Like what's in control of this whole like loop? How do things like feed events into each other, and sort of what happens there? So yeah, the way, like there's a lot of different ways that you can structure that, right? So it's like we have sort of in this little diagram, we just have this event stream thing here, but it's like there's different ways that you could do that, right? It could be like one sort of continuous sort of event stream from like LLM to like parser to like some sort of representation for both the user and for the LLM, right? So it's like you have different ways that you need to display the event stream. And yeah, so I'd say like you basically have things that add to the event stream in different ways, and you have things that need to like perceive that event stream. Is like the main idea, I would say.
So is the right way to think about this? You basically have a function in your code somewhere that's an event handler that takes in some event kind of any of the many events that you have, and then based on the event kind, well, this is center text. You don't want that. What you end up doing is you end up basically saying, hey, if it's an LLM stream, if it's an LLM event, or I should say like a parsed event, then you do something else where like maybe it's like send to UI of some kind. Otherwise, like if it's a tool response of some kind, you say like do action, where you do the next action over here.
Right.
And you go build this out. And then if it's like if user request, you end up saying something like queue action of some kind, where you like queue an action. And this is basically just triggering almost like a cron job that's running all the time, where like every single system that you have, like every agent task isn't actually a whole loop. It's actually a system that's just adding a new event to a massive
Yeah,
like event log of what's happening.
exactly. Yeah, I think basically the way I think about it is like, yeah, it's like a reactive system. So it's like it's not, instead of like thinking about it as like a while loop, it's more like queues of events,
Yeah,
right?
so your worldview model, and so that's interesting. It's actually a different worldview model than what I've used in the past, where like my way of representing the worldview has actually been like I have a giant state object that represents the state of the world of some kind. It sounds like your worldview is actually you have like a vec or an array
Yep.
of actions that have happened in the past, and this is what represents your state. It's not to say either one is good or bad, but this is what you found is really easy because then what you say is, for example, the way that you tell me if this is wrong or not. The way that you implement queuing is that you say, like a queue event is a thing that gets pushed into your array, and once the next action finishes, you go back and you see if there's any queued events that are
Right.
not done yet.
Right. Yeah, it's very sort of native to that system, right? So, yeah, so what we had sort of in the past was sort of more like a state-based model where we just have a state and we mutate it, and it's very reasonable, kind of makes sense. Like you can just sort of change the state as needed, react to that, do think different things depending on what that state is at the current time, and that kind of thing. But the problem is like what we did more and more over time is like we started sort of mixing these paradigms because it's like, oh, well, we need like a whole like log of everything that happened in the chat so that we can like view it right in the
Yeah.
chat, and also the LLM needs to be able to perceive it in a certain way in terms of like converting that to something that goes in the context window. Um, and then it
So
became very unwieldy to like maintain both like these events that are like the source of truth for like what happened, and then also like a separate state which is like we have to keep it synchronized with like what happened. And then so basically what I wanted to do instead was just like, okay, what if everything is just basically a pure function of the events that actually occurred? Um, and so like you can have like representations of state in this model where you sort of centralize around events still, but they're just like functions
so
of
I'm gonna
like
try and
that event stream.
describe. I'm gonna try and describe what a user might do and how someone else can view the code, and then we'll take a look at the code really fast. So in this case, what I have is a user started off with some user event that was some request. Maybe it's as simple as just like hello, and your agent started responding with like hello how, really fast, and then right at that point the user said wait. So there, and if they queued the event, the behavior ends up, I'm guessing, something like this, where you get a bunch more stream text
Yep.
events of some other text, and at some point your state engine recognizes that, like obviously when you're streaming, you can also say like done streaming. And now your your agent system can say as soon as the event handler for the done event goes and checks the queue for this specific user ID or this specific conversation ID and says queue event. Well, let's give this event an ID of like ID of some kind. Sorry, let me make it bigger and make this too small. ID equals 1. And then what I can do is I can say like handled event. And now I can handle event ID equals 1, where it'll actually treat this and transform this into another user event of like wait at this point. And now this has basically been handled. So now the system will start streaming and send the response into the user. And that's
Right.
one way to handle queuing.
Yeah, but yeah, the main thing here is that when this queue event happens, right, we have to immediately, right, interrupt whatever thread or is going on that's handling the streaming part, right, and ignore the rest of it right away.
Well, no, not the interrupt, the queue event.
Oh,
Yeah, sorry.
you mean
Yes.
just literally?
It's
No,
like
yeah.
I want to queue
Oh,
event.
oh yeah, yeah, oh yeah, yeah. My bad. Yeah, for queuing events. Yeah, yeah, yeah. So yeah, we let it keep going. Um,
On the other hand, let's talk about the second part, which is interrupt event. Let's say the user sent this as an interrupt instead of queue. Oops. Interrupt. Well, interrupts are, I think, very, very similar to queuing in that same form factor. Where, oh, sorry, 1 second. I have to reload the page so my view length is better. Let me go back to the right area and click on new. So interrupt is very, very similar to queuing, where instead of queuing the event, though, all these systems that come in, what you can tell your backend is, hey, don't add these events to my, I mean, you can cancel it as well, but you can also just say like, just don't add these to the queue. Like basically don't add them into the queue and spin up a new event as if this happened. And you can do, what's interesting here is you can choose how you handle these previous events. You can choose to maintain them in the record, or you can actually say that actually, you know what, these are bad, so I will just like delete them after the fact, even though they technically exist in the record. And my worldview, when I query and when I show in the UI how to represent this exists, but I don't render it. Or I can delete it and purge it from the event record in any way myself.
Yeah, exactly. And I think that's the nice thing about this type of system, right? Is that you can basically just look at what happens and sort of have however you handle events decide like what is supposed to be viewed or perceived when like, you know, this type of situation happens where you have like, okay, these events were streamed, but then the interrupt happens. It's like, okay, do I just ignore the ones that happened after that? Do I ignore all of them? And you can sort of, you know, implement that however you want.
Yeah, and like once you model the world in this way, where it's just like a sequence of elements that are being collected and like drawn upon, like writing code for this is actually very simple, I'm guessing. Like this code system is not that hard. And in terms of actually like rendering in the UI, well, that's also very easy because you just say, how do I render this sequence of events? And
yeah,
you can do that in any which way that you want as a developer. You can render like and show the stream text. We know how to do that. You can render and show queued events. You can not show queued events. You can show interruptions. You can show middle states. You can show like the entire conversation history. You can go back and fork at any point because it just copied this screenshot, copy this action array of everything up before this event and start copying from here.
Yeah, I'd say there's like a little bit of like, just like setup in terms of thinking about your agent as a sequence of events and not as like just, oh, I have state and I mutate it. But like once you start thinking about it that way, yeah, you get a lot of benefits from that. Like, you know, some of the things you mentioned.
You know what this really reminds me of? This really reminds me of how like database transactions are made.
Yeah.
In some ways, where like you basically have, in a lot of ways, you just write a bunch of logs to some event file, and eventually the database becomes like consistent on its own by saying like these event files eventually have to be recorded in the database. With some manner.
It's kind of like that in a way. Yeah. Right. Yeah. So you can, I'd say like, the key things that you can really get out of this are you have sort of, right, you have the one source of events instead of like state that you're mutating on the back end, state that you're mutating on the front end. Those might get out of sync, right? You have all sorts of like weird things. It's like everything just driven by sort of this one engine that's handling the events and that kind of thing. And it can just send like, okay, front end, like you should look like this at this point in time based on the events that I've been looking at.
I'm actually really curious to see what this code ends up looking like in practice. And
right.
Someone asked a really important question before we go into that, which is, do you store the same events in the same table in a database? My hunch says probably yes. I suspect your database is basically a union of events.
Yeah, it's literally just the way I've done this is it's just one array of events just in a database column. It's just
I'm guessing your
just like a discriminated union of different like event types. That's it.
And I'm guessing it's just basically like event. And then you just group by user ID and convo ID, and now you have your entire event history for every single, and like timestamp and obviously all the metadata.
Yep. Yeah. So that's basically what it is. Yeah. So it's just an array of events, and so the representation is like extremely simple, right? You can just load those events and do whatever you want with them.
Yeah, and you can load as many of the events you want. You can get the most recent 50. You can get all of them
it's
forever.
Like,
you can get the first 10, the last 10. It's all up to you.
Yeah, and it's extremely like debuggable and testable as well. Like when you think about like one thing that was hard when we were sort of building our chat is just like it's hard to test it without like running the back end and the front end and like testing different scenarios like manually and that kind of thing, like with sort of a traditional system where you have some sort of state that you're managing on the back end and on the front end that's trying to synchronize, because you don't really know from the back end code alone what the front end is going to look like at any point in time. But if you have sort of everything driven by the events, and like your back end is basically just telling what your front end what it should look like exactly at any point in time based on those, then it becomes very testable, because you can just write tests that are like, okay, at this point in time, I expect the interrupt button to be available or not based on these events that occurred.
It's another analogy for this for me is like very similar to like use state in React. When I write use state in React, I can like, well, how do I debug state that is bad? Well, I usually just hard code the initial condition of the state. I say change the state to this,
Yeah.
and like just show me what the rendering looks like, and then I debug it really easily. Because like React just says, assume I have state of this shape, and now render it however I want. And it's a really easy transaction for me to go make as a developer. We should get the code. We got
right.
like 2 interesting questions while you set up the code and you go screen share for
right.
that. Take over my screen share while you go do that.
Yep.
Which is, where do we persist the context for LLMs in this case? And I think this is a really interesting question that a lot of people ask, but this goes back to how we've talked about this in the episode quite a few times, which is what the heck is an agent? Well, let me see if I can pull that up. We talked about this in the 12 factors, selecting thousands of tools from MCP. Tool, let me pull this up really fast. I'm gonna take over the screen share for 1 more second.
Oh, okay. My bad.
That's okay. Share screen. We talked about it in this episode actually. And when you go think about an agent loop really fast, what I have personally found is, I'm gonna take it here really fast. Sorry. You can view every single agent as basically a model as just a thing whose only job it is to do, which is, let me pull this up. You take some context window that you're building up over time and you ask the model to do something that is very stateless, which is determine the next step. See, the question that you're asking is how do you build your context window? Well, your context window is also really just a projection of this state. You take this state and you turn it into a chat prompt of some kind. And that's just a function that you can write, which says, or turn your action array or event array into a chat prompt. Now, I suspect Anders will end up showing this code when he talks through this. But let's get into it. All yours, Anders.
Alrighty.
And as people have questions, keep sending them. We'll try and answer them as fast as we can.
Okay. Yeah. All right. So here's the code for sort of that demo that I was showing. That's sort
Bun. I love it.
Where do you see the bun at?
I saw bun.serve.
Oh. Yeah, bun. So yeah, when I was playing around with sort of the ideas for doing this very event-driven thing, one thing that I had heard about but not experimented enough with was effect TS. And so I'm an effect TS newbie. But for people who don't know, it's like, a library that makes it gives a lot of tools for TypeScript in terms of doing a lot of different stuff like error handling, but also like streams and just like piping things between other things and just like all sorts of different like transformations. And so yeah, basically it became like obvious that like it was like a pretty good way to structure this type of system where you have sort of inherently like a lot of streams of events like feeding into each other and different stuff like that. So yeah, this is a very like, this demo is like very event TS heavy. So yeah, basically like how this has been like structured here is just like effectively like the backend here that's actually receiving the WebSocket connections from the front end and it's running the whole chat has basically these different like services that are at any time going to basically observe events and like maybe produce events also. And so these are all sort of controlled by like an event bus, which is like going to be getting different events from like the front end. Say a user sends a chat message that will go in here, right? So it's like, let's take a look at a specific example. Um, yeah, so it's like basically when something wants to send an event back into sort of the engine that's has these different things perceiving the events, it can use this event bus. It can like publish the event, and it will basically be subscribed to by the other things. So
let's take a look at some of the events if you're down. Now, why don't we look at
yeah, let's start with the events, right? So yeah, so here's what some of the events looks like, for example. So basically, these are all the types of events that can live in this event bus and can be like sent to it as sort of like from external source or like sent from one of these event handlers back into the system to be transformed or something. So like user message, obviously that's like going to come from the front end, and it's going to sort of go into the system and it'll be reacted to in some way or another depending on like what's currently going on. So like if we look at like oh man, I've got like, hold on, just delete this.
Yeah, you can just filter for .ts files. Just hit the down arrow on the left, or the dots. If you need to.
Yeah.
There you go. Or it might be TSX if you're looking for your front end. There you go.
No, but it's like, yeah, so it's like, this is like the message function that's just like on the server itself. So like when it gets a WebSocket message from the front end, that's like, I want to send a user message, then it will basically like publish that to the event bus, right? And so we can see like what uses that, right? So we have basically a subscriber to that event bus, right? Which is like this messages state service, right? And basically what this is just trying to do at any time is actually basically trying to like perceive like a current state out of what events are being streamed that have to do with, that are like message related, right? So it's like user message or like different like LLM chunks or other things. So basically, right?
And this is interesting. So it's not that you don't have a state object. It's that you don't keep the state object as your representation of truth. You have an event. You have an event history, and you turn the event history into a state object every single time you do something with it. Exactly. So then you say, now given the state object, now what's the next action?
Right. Yeah. You could, right. So you could imagine like in a sort of normal like state-based system where you're just sort of like mutating state, you would just have an object like this, and you would just initialize it to this, and then like you would be like, whenever you finish streaming a message, you'd like append it to this list or something, and like whenever you get a message and you look at everything and you're like, oh, I think this should be queued, you would add it to here instead, and then you'd like move it between these or something. So all we're really doing here is like we're saying, okay, we're still gonna like, this is still helpful to like perceive something as like a state of like different things in a certain context, but we can construct that purely from the events that are actually happening in a specific way. So that's what this is really doing here, right? This message state thing is it's just perceiving the event stream as like what's currently going on with the messages. So like, are we streaming? Are any of them queued? Like how many tokens are we using? Like all that kind of stuff.
And this can change at any time because it's just a simplified view of the event history, because you're like, I don't want to look at the time at which queued events happen. I just want to like pull out all the queued events and just have them available really fast.
Exactly. Yeah. You can just decide exactly what this needs to be, like what information is important to hold on to and that kind of stuff, right? So yeah, and then so like an example of like something you'd actually do, right, is like if we look at what's actually happening here, right? So it's like processing user messages. So this is a specific stream for just the events that have that type user message. So these are basically coming from the front end through the WebSocket. And basically we have this stream to handle those specifically. And basically based on our current state, right? So we're looking at our current state, like if we're streaming and that kind of stuff. So if we're currently streaming, we aren't going to send it right away. We aren't going to trigger the LLM to start streaming again. We're just going to update it, and we're going to put that in the queued user messages, right, instead of the normal messages. And otherwise, right, we just add it to sort of the normal message array, sort of the history here. And in addition, right, we also have sort of an effect, right? So we also trigger the LLM, right, to respond, right, which is just sort of this utility here, which again is checking some things and then it's producing another event, right? So it's like if we get a message and it's not currently streaming, then we're going to queue this event, right? LLM response started, and that's going to basically trigger an LLM response. So we could trace that further here if we wanted.
And the reason, and just to be very clear, like the reason we add that LLM response started is because we want to somehow show in our UI that we've handled the message in some way, or the message is like addressed, and we should show some UI indicator to the user, or like we shouldn't just run another message right now because there's something else in progress at this moment.
Right, so it serves a dual purpose, right? So first of all, yeah, it could be represented in the UI if we wanted, but also it means that we can delegate sort of what it means to start an LLM response to like another part of the code base, right? Which is like more dedicated for that purpose, right? So that's what like this is here, right? So it's like that goes back into the event bus, and now the LLM service picks it up, right? So this is not a thing responsible for maintaining chat state anymore, but this is a thing responsible for basically managing a stream of chunks that come back from an LLM and deciding what to do with them, right? So again, we're subscribing to the LLM response started event, and then basically we're going to listen to that, and then when we get one of those types of events, we're going to do a few different things, right? So first of all, we reference actually a different state, right? And this is sort of a state managed by another service, right? LLM memory state, which is sort of the perception of the messages as context, which we can look at in a second. But basically that gets like messages that are nice for the LLM, and they're sort of like in a format that's ready to go for that.
And the idea is that you can remove all the cruft and state signal. Like for getting messages in the current state, you really only want the final LLM response from every LLM past LLM interaction. You want the chat thread with the most recent views, so interruptions and stream text and everything else is removed. And you really want to simplify this.
You can decide like exactly what you want to go into the context window, right? It's like very explicit. Like it's not like a lot of the times, like I feel like when you're building an agent loop, the easiest thing to do is just like you're just appending messages to like a list when it's like, use like role user this content, role assistant this content. And then everything is coupled together. Like your control loop is like looking at those messages and like deciding what to do based on what those look like. You're feeding them to your LLM, you're trying to display them on the UI, but like when your agent gets more complex, these sort of states diverge. Like what you want to show in your UI is no longer the same as what you want to show to the LLM. And so it makes more sense to produce those states instead.
In different projections.
Yeah,
I think there's a really important question that's happening here, because I think I see what you're doing. You basically have this giant event catalog, and based on different use cases, you're turning it into different subsets of that catalog based on how you want to go use it. So
exactly.
In the case of a new user event comes in, what you want to ask yourself is, the only thing you really care about is anything active happening right now? If something active is happening right now, the new user message is a queued message. Yep. If nothing active is happening right now, the new user message is the next action that should happen next. And I think and right over here, you did another projection where you said the LLM is going to interact, so I want a subset of the messages that I want to send to the LLM. But I think there's something that might be confusing a few folks really fast, which is this really important question. When do they get persisted? Like, I get that I could keep this thing in memory, but like, do you save this into a database anywhere right now? And if you don't, where would you? Because how does that work?
Right. So in this like demo code, it's just all in memory, right? But it's very easy to.
Can you show the data structure that keeps everything in memory? Because I think that would also make it a lot more clear.
Yeah,
I mean, it's doing some magic.
So it's effect doing some magic. So
Okay.
it's all being basically it's all persisted in memory basically in the like the stream buffers and that kind of thing. Um, from my limited understanding of effect, at least, I think that's
Right, okay.
where it
That's what I
lives.
figured.
Right,
So,
but
but if you were to save in a database, can you show the pointing code when you do this? I suspect it's an event bus.
right, yeah. So you could do this.
I
Yeah,
suspect as soon
probably
as
just an
someone
event bus
publishes
would
a
make
new
sense.
event, I suspect you do it on publish.
So you
Whenever
could
a
do it on
publish,
publish, right? But it's like it depends on the frequency of persistence that you want, and sometimes right you don't want to persist everything right away because it's like you could have sort of invalid states. Like you imagine like if someone has
yeah,
just interrupted an LLM in the middle of a bunch of stuff, like it's like oh, do you want to persist it there, or do you want to wait for like the LLM to finish its turn, or like if an LLM is like in the middle of streaming, like it doesn't really make sense to persist it on every chunk, right? So it's like
I
you have
agree.
to decide like when does it make sense to persist it. But basically, yeah, you could have one way to do it was just like you just have a subscriber to all the events, right? And you just have like basically
And can you show,
some,
let me just write some pseudocode really fast, or maybe let's write the code really fast. I would show how it get persisted in effect, I think. Also, for those of you that don't know, effect is actually a pretty good library. If you're trying to build an extremely resilient system, effect will make it easier to go do that kind of thing. And in the world of LLMs where you have a lot of error handling, it is easier. But that said, it is clunky to learn.
let's ask Claude Code because I'm not very good at writing effect, but Claude is pretty
Okay,
good
yeah,
at
I can go right into you, but this is okay.
it. How would we persist all events in the event bus so we can reload the chat later?
Yeah, there you go. It'll figure it out. And it will go write the code. And I think, and we'll be able to see a Git diff really fast as well. So
Yeah,
that'll
we
be
could
really
be
easy
able
for
to just
people
look
to
at the diff. So that will give a little
So
proof of concept.
while that's running, thank you for queuing that up. Let's go
Yeah.
continue reading the code.
Yeah.
Um,
So yeah, maybe we could look at another example of sort of one of those projections.
Let's look
right?
at, I think the question there was actually really good, which was how does this actually go into an LLM? I think we should go look, I want to see your projection of what events are you discarding when you create this giant event array from all the possible events to the LLM memory state. And if you could put side by side the LLM memory state that you're building, and on the other side, if you can put and on the other side, you can put all the events. So we can
Yep.
actually just like see it side by side. I think
Yep.
that'd be really cool. And could you hit command? Yes, exactly. Thank you.
Oops. There we go. Right. So, I mean, in this example, right, the events for the LLM we're just sort of rendering it out to just a simple message with,
Yep.
user assistant role and just string content, right? And then we have all these types of events that could be encountered sort of over the time where it processes events. And yeah, so what we do is we basically we can listen to the specific events that we care about or not. But in this case, we're actually looking at the message state. So we're actually looking at another state in this state, right? So
Okay.
we're looking at the messages state, which we looked at earlier, which again is basically just keeping track of a list of messages and some other information. And because that's really the only thing that we care about for showing the LLM in this case as well, it makes more sense to just look at that than like redo all that logic of like trying to figure out when a chunk should be appended to the last message and like all this different stuff. So the LLM memory state here, which is constructing the specific messages for the LLM, is just going to tap into that state that we've already constructed. So it's just mapping those messages that are in that state to, right, these simple versions that can be passed to an LLM. So in this demo, right, we have sort of text events, which are just like, from the user to the LLM or the LLM to the user, right, just sort of standard messages. Or we have like function calls, right? So it's like basically we parse the LLM response and we decided, okay, this is a function
Can you
call.
click on that format function call so people can go see this? I think it's going to help make it a lot more tangible.
Yeah, so this is like, basically the function syntax that we told the LLM to use for context here, right? So we told it to use this sort of XML format, right? So when the LLM responds and wants to call a function, it does something like this. And so we parse that out, right? And we can validate the parameters and that kind of stuff. But then instead of storing it directly and sort of feeding it back, since we want it to be sort of this clean format as an event, we have to just reconstruct what we want the LLM to see that it said, right? So basically we're reconstructing that format for the function call here.
Got it.
So
And that's just so you can keep everything be really in sync with what you want to do. And you
Exactly.
could have done this, in many which ways, but I'm guessing you just found that since you're doing code gen, I'm guessing XML works pretty well.
yeah,
for
so
that.
this is the same
Exactly.
XML format that like Anthropic models use internally. So
Yeah.
we just imitate
It's good
that.
to mimic it. Exactly. Yes.
Yeah.
Especially if you're using Anthropic models, you should just mimic whatever they're doing.
Yep. So that's why we have that specific
Cool.
format there.
So it sounds like really, I think the big takeaway for almost everyone that's on this, and like, well, if you're down to, you should commit this code to the AI that works repo in the folder for today's event. I think people might have fun running this code and playing it out with them for themselves and just like understanding what's happening.
Yeah, sure.
But just things like some final closing thoughts as we're out here. And also, if people have questions, feel chime in. We've got a pretty hard stop today, so we'll be stopping right on time. So what's the big takeaway here? How hard, in your mind, how hard is this to build? Like on a scale of 1 to 10, 10 being like Linux.
So I think the real question here is like how complicated is your agent? Like how many interactions and like possible states are there at any point in time? Right. And like if you're building a simple, back and forth chat agent, like this is like completely overkill. It's like you can just store the messages and just show that and to the user, show that to the LLM, like whatever. But yeah, the reason that I started thinking about this in the first place is that we were just sort of, we have so many different things going on in our chat UI and our product because like, we have like,
You can screen share again and show what you mean.
right. So we have a lot of different things
you can build a full plan. You can run. It could be running code, and maybe you want to change the code. Maybe you want to change the pipeline while it's running the pipeline. Like that's a
Right.
very complicated interaction to model.
Yeah, it's like I could be like, also email this to myself.
Yeah,
And it's like,
it would
okay, now it has
really
to think
suck.
about like, it has to think about like, okay, what's in the current workflow? Like, how do I? Oh yeah, it's also seeing like errors. It's also perceiving errors like from the workflow runs. Like when we run it, it will also like know about what happened during the run. So it's like making a fix based on that.
The thing I think that would really suck about that, which is you said also email to myself, maybe you've been running the pipeline for like 15 minutes already, and it's been running and collecting a bunch of data, and now it's basically just going to throw all that away and make a whole new pipeline,
Yeah.
and then say, now let's run it again. And whereas if you did it with your event-driven system, you could say, this is how I want to modify the pipeline. You could run another event that says, what's the diff of this new pipeline versus the old pipeline? The diff is very small, and now it's basically just kind of working along the
Right.
way.
Yeah, but basically, right, yeah, we have like a lot of different types of interactions happening, right? It's like it's editing. So under the hood, this is basically like a coding agent. Like the workflow is code and it's editing it.
Yeah.
So it's like a coding agent, but then it's also like adding these connectors which require like a specific OAuth flow, which requires like human approval. And then it's also like proposing these plans, and it's like, okay, the user has to approve or reject those. And it's like, okay, if they approve them, it has to also ask for the OAuth. And then what happens if they reject one of those? It's like all these like different variations of state. And it gets like really unwieldy if you don't have sort of a system for like understanding it, right? And I think having sort of everything be a projection of the events allows you to like have very clear views of those events in the exact ways
Yeah.
that you need to actually understand what's
And
going on.
I think it's kind of like React, right? Technically, use state is really, really overkill. All you want to do is build a website. But it
Yeah.
turns out the minute you add interactivity, it's There's no simpler way. And that
Right.
little bit of complexity just makes it a lot easier to build that website in the way that we want to. But over here, it's the same thing. Like, yes, it's a little complex to think about everything as a projection from like your event history and your event array. But once you've done that, you really have a beautifully simple system where everything is really just a read-only interaction on the current view of the world. Here's my
Exactly.
current worldview, go do something with it. Here's my current worldview, and it keeps changing. And someone asked a really good question. It's like, could tools also write events to the stream? The answer is yes, they definitely could. Because they're just adding events to this database that we have. If I were to share screen again, 1 second.
Yep.
If we go back to what we were sharing over here, what everything is doing is fundamentally we're just adding data to this database, which is user ID, convoy ID, and event. And you just keep pushing more and more data into that. And that is your current worldview. And the next time your system runs or handles on event, you just go do that. If any of you have ever built like an event handler or a webhook service, that's basically what you're doing. An event comes in, handle the event, you get the worldview, and you go do stuff with it. It's, funnily enough, this paradigm exists in so many elements of software. The more and more I think about it,
Yeah.
like the more I'm thinking, like this is just everywhere. It's just that most of us haven't had to write code that has dealt with this, so it feels really foreign. But all of us have used code that has done this in some form factor or another.
Yeah. Yeah, it's just sort of like it's a product of the chat loop gets really complex and ugly.
Yeah,
It's just
the
like
chat loop is so disgusting to
and it's
maintain
like
forever.
and it's just like ew, like what I'm like holding these
Yeah.
events, like I have this chat history. So basically like before I was like had this like, history of events for the UI, I had like event like or like messages for the UI, messages for the LLM, some sort of like mutated state that's like tracking other things. It's just like geez, like I can't even think about like what's happening at any point in time. So it's just like very, very non-productive at some point when the chat agent gets complex enough. So yeah.
So I think we're gonna have to close it off here. I've got sadly a hard stop today. Normally we will stay on for questions and answers. Now, if any of you do have more questions about this, definitely we'll send out an email update with this and send your questions there. You can definitely ask questions on the BAML Discord as well. We'll post a link on there in a second as well. And you can find the link on there. If you want to sign up for next week's episode, we're gonna have another really fun episode. Sign up on our link over here. This has been AI That Works. We've got Anders over here helping us actually wrote a whole demo, made it work, showed event-driven actions in a really cool way. So thank you for making time for that. Follow them on Twitter, check out their demo, check out their product. It's really freaking cool. It gets really deep, and I'm super excited once you have the event-driven loop you showed in the demo live in the code. It's going to make it even more fun to play around with. But for everyone else, thank you for making time out of your day to come listen to us. This has been fun.
Yeah, that was fun.
Another episode out the window. All right, we'll send an email update to everyone that's watching. Thank you, everyone.